Whether it's one person or multiple people, you can't do the exact same thing over and over again all day for hours. It's just a lack of consistency, and the results show that every time. And based on the tissue, how it falls apart, how I've cut the tissue, all these variations come into play. Whereas when you go to a more automated system, none of that really matters because the device is doing all the work for you.
Welcome to another episode of the Omni Pod, where we're enabling conversations between life science thought leaders to help you get the most out of your preclinical research. Today, Rodney and Bill are talking about why manual prep can feel unpredictable and how automated bead milling brings tighter runs and fewer headaches for downstream analysis.
Rodney, thanks for hopping on with me today.
Thank you for having me, Bill.
Tell me a little bit about your background and how you started in the field.
Absolutely. So I am Rodney Nash. I am the Chief Scientific Officer here at Omni International. Of course, we are a division under Revvity. And I started many moons ago. I was undergrad at Georgia State University doing molecular cell biology, doing some HIV research. I also did my master's degree there, and then I went to the University of Georgia where I did my PhD. I did a lot of animal cloning initially, and also a lot of stem cell work, Went to Emory University for my postdoc, where I wanted to kind of get a feel for the clinical side of things, taking all that great knowledge prior and trying to apply it to the living clinically was what my goal was. And I went to Emory and was in anesthesiology and neuro, and then went over to pediatrics and started a small biotech company, and then joined this group here.
Along the way, you've done sample prep for all manner of things. How has that, I think, over the years changed? How have you seen it?
Well, let me tell you, I happen to have something with me here. It's the Dounce homogenizer. This is what I always use. This is the traditional way of doing sample prep, taking a piece of tissue or taking cells and putting them in that instrument with a buffer and trying to just being able to punch this consistently over and over again is very difficult. Think of a piston in the car and how it fires repeatedly. And if it ever gets off timing, we have misfires and we have to go get this fixed, of course. Well, there are a lot of misfires when it comes to sample prep too, and people don't realize it until downstream when they look at their sample and they're trying to figure out, looking at the result, and trying to figure out why am I getting this? This is not what was published before. This is not what I expected. And so that was what I did traditionally, using different detergents also, and that has a key impact also on what you can do downstream. And again, trying to repeat that, Bill, over and over again, as perfect as I think I may be, I'm really not as perfect as I think I am at times.
What are the most amount of samples you had to process?
Oh my goodness.
In one project?
I remember a study that we had where we had 120 individual pieces of tissue that we had to run, and it was not fun. Took a very long time, took hours and hours. It's an all day, all hands on type event. And that being said, this is where you can have variation as well, because whether it's one person or multiple people, for instance, if it's one person, you can't do the exact same thing over and over again all day for hours, take a break and come back and, oh yeah, I'm going to do the exact same thing again. It's not going to happen. So if you have multiple people with the interest of time at hand, now we have different hands and they all operate differently. Even my right and left hand don't operate the same. So imagine on a different person how that would work. And it's just a lack of consistency, and the results show that every time.
Explain that to me, because I don't understand. I mean, I'm processing the sample. Isn't it processed or not? Why does that variability really matter to the work I'm doing?
Well, what happens are the forces that this generates over and over again depends on my consistency. Depends if I'm twisting it or not, or if I'm just going straight up and down, how many times I'm doing this, and the types of forces that it introduces, be it torsional forces or steric stress forces, etc. It really depends on my consistency, how much force I consistently add to it over and over again. And based on the tissue, how it falls apart, how I've cut the tissue, maybe my lab may cut it a little differently than I did. All these variations come into play. Whereas when you go to a more automated or even semi-automated system, none of that really matters because the device is doing all the work for you repeatedly over and over again. For instance, again, with our bead mill, the Elite homogenizer is a great example of that.
That makes perfect sense to me. And what is the impact down the road if I have that variability in the way that I'm prepping the sample? What is the material impact? Is it on the data? Is it on the fill in that gap for me? Because I think I'm missing that.
Absolutely. It's on the data. So let me give you an example of having a poor result. For instance, in the publication that we had recently, we were able to show where using this actual Dounce homogenizer here versus our bead mill to my right over my shoulder, we were able to look at a basic biological unit, beta tubulin, which is found in every living organism that we know, every system. And it's pretty universal, irrespective of if it's drug induced or the experiment, or if something's being suppressed. It doesn't matter. We're going to pretty much find a uniform amount of it there. Well, when we use the manual Dounce homogenizer, which I just showed in my hand, we did not get a consistent result. The result varied with differences greater than 30%, which statistically is not good. When we use the homogenizer, our Elite homogenizer, again over my right shoulder here, results were definitely between 3 and 5%, definitely believable, repeatable, and accurate. The samples that we use this on actual biological samples, use it on placenta and umbilical cord. If you're doing, for instance, some kind of testing for any kind of a genetic screening, etc., this is important that we have the proper homogenate developed for the proper release of our target downstream. This could be a key factor in determining a child's outcome with regards to disease, etc. So it's very important to have the right process. Again, sample prep, people think, hey, just break it up and it'll be good. We have a saying where junk in, junk out. And again, when you're looking at newborn screening, any kind of, for instance, if you're doing drugs of abuse testing, which we do with several of our clients, it's very important. And lack of proper prep can really make a huge difference. Also with genetic screening, when we're looking at just trying to get good quality nucleic acid, sometimes with the way, again, if you're using a Dounce homogenizer of this sort, and turning sometimes can introduce too much torsional strain and force, and you can shear nucleic acid, and you're looking at your sample and you're thinking, oh man, well this didn't work out well. It's the prep you did. It was the actual prep. Just simple things like that. Looking at simple everyday things in a lab can be affected. Looking at what we would say are post-translational modifications, phosphorylations, methylations, acetylations, which are very important for looking at gene expression or transcriptomics. So looking if a gene is turned on, if you're looking at a drug treatment and you're trying to say, hey, is this gene, did this drug, this cancer drug, for instance, suppress this gene? Or did it turn this gene on? Simple sample prep can be the determining factor of determining that.
I think that to sort of extend on that, I think at one point we talked and you had mentioned that bead milling, you could actually use fewer cells to get to the result that you're looking for. Can you talk about that a little bit?
Absolutely. Again, referring to the article that we recently published, what was recommended, so we compared our method to a commercial kit, and what was recommended was 20 million cells. And when we used our method with the 20 million, we literally were just bleeding over. It was just so much. So we dialed it back to 5 million cells and got, with 5 million, 1/4 of the actual recommended sample amount. We got more than what they got with the full amount they recommended. And what that says is that we're having more of a complete homogenation, a complete homogenate that we're producing, and we're getting all the actual targets released. And think of that for a minute. It just saved you all those cells, all that extra growth, the media, the time to do that. You can have your people doing other things that are important, and you're saving money, you're saving time, saving manpower, and you're getting a better result and a more consistent result. So sometimes people will saturate samples to make sure we have enough of this here. Let's grow and put so much in there, and that's fine. But if you can save yourself time and money by not even needing as much sample, then also there are circumstances where, again, if you're looking at human samples, for instance, a tumor. Sometimes you're not given a full tumor. Most of the time, you're not given a full tumor. You're giving a hole punch, a little small, maybe 1 or 2 millimeter size piece of a tumor. And it would be great if you had the full, 5 centimeter tumor to work with, but it doesn't work like that in real life. Pathology gets most of it. They're looking for certain stages of disease. You're looking for something different, maybe some genetic profile, et cetera, for drug testing, et cetera. You're not going to get as much as you want. Using the method that we developed shows that, hey, I don't need as much. I don't need as much to get that full homogenate, and those targeted analytes are released.
So you make a really good point there, and maybe we should back up for a moment. Introduce the publication that you just mentioned. Improve sample preparation using bead-mill homogenization.
That's correct. So we published that paper this summer, and the goal was to compare, again, this instrument here, Dounce homogenizer, which goes back 100 years plus. This has been used, and it's basically just a piece of glass, silica, and it's one blind end, and you have a pistol where you just introduce and you grind and you turn over and over again repeatedly. Comparing that method to our bead mill right behind me, my wonderful friend right here, the Elite, 24 samples versus 1 sample at a time. What I was able to do using that Dounce repeatedly took several moments. I did 24 samples in 30 seconds and I was finished. So
Wow.
in this particular technology is using beads. So the beads in particular we used were ceramic beads that were 2.8 millimeter in size. So they're not real big. They're pretty small beads. But again, what it does is it introduces introduce force, some shearing force, torsional force. With the bead beating also, you get some impact force. You get a little bit of friction as well, which you do not get as much with the Dounce homogenizer. So these extra forces, they're consistent and they tear apart the exact same way. So in the publication, we were able to show, looking at human samples, looking at placenta, and also looking at cord, which again are used for various reasons. Everything from drug testing to any kind of genetic aberrations that could be found in the newborn, genetic screening. It's used for that purpose. But again, it requires a complete homogeneity. And what we were able to show, again, just looking at basic subunits of beta tubulin, which are consistent in everything. It's like air in a cell. It's equivalent to air out in the room versus, if you had helium in a room, regular breathable air. Beta tubulin is just found everywhere. It's ubiquitous. And being able to use that as a target, and we were able to show where, yeah, we could use the Dounce. It definitely works. There's no doubt about it. But the results were so inconsistent. Again, 30% plus variations in some cases, whereas with the Elite, we had statistically significant results where under 5%, the consistency. And again, not needing as much time, not needing several hands on deck to do 24 samples. There's no way you're going to do, you have to clean this over and over again. Now you're looking at cross-contamination, carryover, not with our device. Our device, one unique tube for each sample. And again, the fewer amount of cells, or in this case, tissue, that's required. One other thing also is when you're looking at certain samples, if the sample is formalin fixed, which is a preservative that's used in a lot of samples. Say if you have a sample you want to go back and look at from years ago, you put it in here, the Dounce can affect formalin fixation, so it won't break everything apart as readily as our device will. So these are just different things that come into play, and you don't always realize until you look at your results and you're wondering why I'm seeing this much of of a cascade versus what's being published, and I'm using the same amount. I'm trying to repeat what's been done, and I can't get it. And these are little things that come up, and we just don't think a lot about it, but it's really important.
Yeah, I think with sample prep, it's one of those things that we just don't spend a lot of time thinking about. In fact, maybe while we're doing it, we're thinking about pretty much anything else.
Yeah,
You know,
we're always thinking about. It's kind of like if it's Thanksgiving, you're thinking about the turkey, you're thinking
hmm
about the cranberry sauce, and if it's me, I'm thinking about the football game afterwards too.
yeah.
But you're thinking about all these great things that you want to enjoy. But someone sat down and prepped all that food, and imagine if it's not done right. If you leave the paprika out, or if you put too much salt, or you just don't do the prep right. And it's kind of how it is with sample prep. If you don't do it right consistently, how are you going to compare this? And you're doing longitudinal studies. How are you going to consistently do this over and over again and expect the results to be believable?
That makes perfect sense. I'm curious. You listed off a number of tissue types or cells. Why did you choose what you chose? I think you mentioned HEK, umbilical cord, placenta. Why those for the study?
The goal was again, trying to pick something clinical, and again, Revvity is the leader in newborn screening. Here at Omni, we do a lot of work with the tri-blood spot cards as well, and it's something that kind of stood out where, excuse me, where we were thinking, something that's very relevant, that's out there, that kind of falls in line with what we do. And plus, instrumentation downstream, we make several of those different downstream devices that are used for analysis, for looking at everything from reformatting samples to doing chip array analysis, imaging, etc. So it just seemed very relevant. But we've also looked at other things from nails to hair to teeth. Um, we've looked also at inorganic things such as rock, PC
Yeah.
board. Company wanted to actually homogenize PC boards to get gold out of there. I didn't know gold was even in there, and I've been throwing
Wow.
away these boards for years. I could be a millionaire probably. Uh,
Right.
there's some very rich landfills right now that I've helped out, but those were very relevant samples to what we do on a daily basis.
hmm
And in addition, also looking at seeds and things of that nature for genomic analysis as well.
And with those results, you talked a little bit. You're maybe seeing higher protein yields and lower variability. Whereas I imagine going into it, you had an expectation, right? Um, was there anything that surprised you out of that process or that study?
What surprised me really was the variation. I've used this for years, and I have so many publications using this. Back when I was in school, I wish I had our homogenizer back then. I probably wouldn't have had so many long nights in the lab. I would have had sample prep done quicker and on to the results, and maybe would have graduated sooner. Yeah, the variation with the Dounce really surprised me. What we've seen in the past, the results from the Elite and the BR96 and other devices that we have, and we know that they're very consistent. So that wasn't a big shock to me, but just the comparison and the variation, and again, sometimes you don't realize, for instance, how much pain you're in until you take an aspirin or take some kind of prescription drug to help you with that. And it's kind of like you don't realize how bad your sample prep is sometimes until you do a comparison. And it's like, wow. And that was the purpose of the publication, was to show that, hey, don't waste your time, chasing your tail. If you want consistent results, this is what you need. You need this, the BR24. You need the Elite.
I think you make a really good point there. You're able to use, in this case, a quarter of the material, and get a fraction of the time all around you're saving. What is kind of the bigger implication for me in my experiments or my processes? If I've got kind of day in day out processes, what do you think the implication is as far as my planning goes, and what impacts that might have for what I'm doing?
I think what it shows is, in the beginning, the most important part, again, the sample prep. is you can trust the fact that it's going to be consistent, and your result downstream, you can believe that as well. Again, if I'm, excuse me, if I'm putting in a sample that I believe to be the proper amount and I'm getting the proper yield out of it, but yet downstream I'm seeing a downtick in the expression of RNA or protein translation, is that really the result of my experiment, or is it possibly my sample prep? This shows that worry you don't have to have. You can just really focus on the downstream analysis, which is where we all want to get to be quite honest with you. We want to look at the result. If we could blink and make it happen, we would. And that's the problem. Again, we kind of skip over it again. And again, I compare it to the Thanksgiving dinner. If you skip over those little things, preheating the oven, preheating the oven, and just throwing that food in there during the preheat does not give you the same result. So it's just very important that the sample prep is done properly.
Let's say I'm running a small lab and I'm tight on resources, staff, money, samples. What do you think is the first thing that I could start looking at to make a change here, to try to do this instead of what I'm doing today?
Right. Well, the great thing is that we have different devices. There are different price margins, and depending on your sample. For instance, if you just are running a small lab, small number of samples, maybe 24 is it's just too much. Well, we have units that run 12 samples, some that run 4 as well. But nonetheless, we have different devices at different price points that can help you with that. One thing also is startup labs, small labs. You want to, again, make sure you have proper results, because downstream, you really want to apply for that grant, apply for the additional funding. And one huge thing that when reviewing grants is the whole methodology. How did you do this? And if you're showing that, hey, I have a consistent methodology, I have a semi-automated method or a fully automated method. For instance, using we have our LH96 or robotic unit that's fully automated, that also can create complete homogenates for tissue and for cells as well. But to show that consistency allows for building up to the larger setups, et cetera, for a smaller startup lab. And I understand that. What a lot of people do also is they, for departments, for instance, they will, the department may purchase a unit for multiple labs to use. That's another solution that we work with different universities also as well.
I like what you're saying, but I have an established protocol or a method or a workflow, or I have things in place, and wow, I'm going to have to go through some red tape to go from, a Dounce detergent to something that's, like a bead-mill or more automated. How is that as really a big of a challenge as I think it is? And how might I make that a little bit easier, given that I'm super busy right now?
Well, let me tell you, you have this wonderful team that I have here at Omni, and let me tell you, we love to get various protocols, make them better. It's one of the things that we offer. It's no additional charge. You have one of our units. You say, hey, and several people have come and said, hey, I have this sample. I'm running, just off the top of my head, whale blubber was one that we worked with. Pig tissue, also looking for trichinosis, the actual flukes that are in there. We can design the protocol for you, which saves you a ton of time. Let us use our resources, and we give you a full, complete, proper report that you can then use with your personnel and duplicate what we did here. And it can go right into your, for instance, a publication or grant writing. So that's a service that we actually offer. That's no additional charge. Not many people do that. We do that.
I don't think anybody knows about that.
Yeah, we do that.
Okay, so you do that for free. Now that is if I already have an Omni product in-house. What about if I don't? I'm looking at what you have, and wow, it seems really great, but I'm not using Omni today. What do you have for me? How can you help me?
Right. So several times we will have our sales team propose something to us. We have our weekly meetings and we will say, okay, let's tackle this here. This is a potential customer who's interested in this, but they have as you mentioned, a conundrum where they're trying to determine how do I get my current prep to include this here. And they may not have the time or money to risk if it doesn't work for them. So several instances where we've gotten and several times they will actually send in a sample to us because they may have an exotic sample. And if they're willing to share their sample, we can do it for them ahead of time and and again, give the result because the goal is for us to win you as a customer. But if we're not the ideal fit for you, then that's okay as well. We want you to have a very good experience and make your science better. Good science is what we are into, and it starts with us. And if we don't have the ideal fit for you, then maybe we can direct you into the area of technology where you need to be.
And I don't know any other company in the space that does anything like that. There might be others out there, but I haven't heard about it.
Let me tell you,
And
we've done this in the 8 years I've been here. I have seen three customers, I think maybe a fourth, that we have didn't it wasn't quite the fit, and it was typically because of volume. They had some crazy amount they were trying to do at one time, and I was like, well, we can do it, but we can't do that big volume. We can do these other volumes for you. And what happened? They got another device, and heat generation, other issues came into play, and they said, well, we like to maybe try now your device and we'll break it down into the smaller volumes. And it worked perfectly for them. They came back like a year and a half later. And, we're very transparent. If we can't help you, we don't want to waste your time. And again, it's about making good science and also having good relationships with people because this is a very, very small world, this science thing that we do. And you don't want to have a bad experience with a customer. You want to have everyone happy and they're happy when they have good sample prep and good results. And that's where it comes from, good sample prep.
that's pretty amazing. That's a great story. What do you think is most exciting coming up in the industry?
I think this whole thing with single cell is a great area where we're able to make single cells. I think that's really a wonderful market that's out there because it gives very personalized medicine, and it's an area where several of us, several are already in, and we are looking at putting a footprint in that as well, coming soon to a theater near you, and that's something that I really believe is a big game changer, being able to make single cells from viable tissue, and the cells are viable, and being able to turn around to downstream analysis that is of value, meaning DNA is not sheared, cells are actually viable, where you can actually do various treatments with them, drug treatments, etc., and being able to analyze various analytes downstream. So that's the real hot area, big area. Sequencing. But you have to have good sample prep in the beginning. If not, you will end up with shared RNA, RIN values are on the floor, and no one's happy.
And so with some of these future things, people are going to be setting up new labs. So imagine I'm a PI just getting prepared to set up the lab of my dreams today. In those early days, how do I choose a sample prep method or platform or device that really will last for me?
Yeah, most PIs when they're starting up, setting up something, it's typically they may have found a prep that they think may be ideal, typically through the literature, etc. And what I always recommend is really looking at the actual result at the end, and looking at that result and saying, okay, they use detergents for this, and detergents I know can affect a sample this way. Is this truly what I'm looking for? This same type of result here. Because again, I think the cleaner a sample can be in the beginning, the better the result would be. So in other words, depending on what you're doing, sometimes you have to use a detergent if you're trying to free up certain type of lipid rafts out of from a protein. I understand that you have to use detergents, but for the most part, a lot of times it's just because we've always done it that way. And depending on the downstream analysis, if you can use certain ionic, Zwitter ionic, certain ionic detergents, some you can't, depending on if you're doing mass spec, etc. So looking at what you're trying to do downstream, that would help me determine what I have to do at the beginning. And again, trying to stay away from things like detergents if you're doing mass spec downstream, because of course they interfere and they cause a lot of interference at times, and people end up doing in gel digestions, having to cut the gel out, and that takes a lot of time. That's what I did. It takes a lot of time. If I'd known what I know now, again, I would have probably graduated sooner. So I would definitely look downstream. What am I trying to determine? And in the beginning, how can I minimize, how can I clean up certain things? Or do I even need a cleanup step if I'm going to process this way? If I'm going to, for instance, again, homogenize and have a nice clean prep versus, a Dounce or detergent and a vortexer. That's so inconsistent, but that's what people do.
And you said something that really resonated. If I'd known back then what I know today. So give me three things that you would, if you could time travel and give some advice to yourself. What are a couple things that you would share to maybe save yourself some time and headache? And
One is what I just mentioned, the whole sample prep. There were so many times at the University of Georgia when I was there at the CCRC, the Complex Carbohydrate Resource Center, and sample prep is key there because everything is mass spec, NMR. It's so crucial. HPLC, everything is crucial. Separation is huge. And so many times I slept on that lab floor running samples at night, doing these gel digestions because that's what we did. We didn't have a device like this, a homogenizer, to break this apart. It would save a lot of time. That, and also I think the number of samples that I ran, if I'd had this sort of sample, I could have run more samples. I was so restricted because it was just me. You're doing a PhD. You're supposed to show what you can do, not what a team can do. So it's just me. And why did you choose N of 5? Well, statistically, it's relevant enough. It's better than 2. Not quite as good as 10. But with this here, we could have run a whole lot more samples and growing cells. It could have been done in one evening versus 2 and 3 evenings. And I guess if I had a third, having a device as such would have also allowed me to broaden the sample type I would have wanted to use as well. Again, when you're limited with how you're processing the cells, that limits the number you can process and the type of samples you can process. Could you have done cells and tissue? With the publication we did, we also did cells along with tissue, just to kind of show that, hey, we're not playing tricks with just the magic tissue. Well, we ran cells too. And I believe they were hex cells, which are just universal. People use them all the time. And they use them for drug development as well. And there's another reason why we chose those cells. And even with those cells, we were able to show that there's no hocus pocus here with just plain cells using a Dounce versus my wonderful Elite. The Elite wins every time. It's consistent, and I didn't need as many. Save me money, save me time.
is there anything on your end that you think somebody who is doing a lot of sample prep or managing that process, they should hear that we haven't talked about today?
Absolutely. I'd like to add that don't be intimidated by sample prep. Again, we typically do, I would say 80% of what's out there, it's very much a myrmidonic approach when it comes to sample prep and even downstream analysis. And you're limited downstream based on what you're doing upstream. So don't be intimidated. Don't be afraid of stepping outside. Again, people like myself and our team here, we're here to help and to broaden what your interests are, and to make sure that you have good science, good results. But it all starts with good sample prep in the beginning.
Rodney, thank you so much.
Thank you, Bill.